So today, once again, we're going to be talking about more properties using matrices. But before we get there, let's think back to what we've learned so far about matrices. We have learned how to add, subtract, multiply, and take the transpose of matrices. But what operation do we typically talk about that we haven't talked about yet? Yeah, that property is division. So unfortunately, we don't have a division for matrices. You can't divide by a matrix. But we do have something that's very, very similar. So to illustrate how this is similar, let's first just think back to something we know and love. If we were trying to solve an equation like ax equals b, what do we do to both sides? We divide both sides by a. I'm sure you're like, yeah, no brainer, Abby. So this basically, we want to cancel that out, so this is basically just a 1. We know 1 times anything is just itself because this is the multiplicative identity. So we're just going to end up with x equals b over a. Okay, now let's think, this is the same thing as doing, if we have this equation again, as multiplying both sides by 1 over a. So this cancels out, so now we have left with 1 times x equals b over a, and once again we know x is equal to b over a. So this isn't too complicated, you know what we're talking about. But this is the part I want you to take special attention to. So we see here that 1 over a times a is equal to 1. We can write this as a to the negative 1 power, or a inverse times a equals 1. Similarly, if we have a times 1 over a, we know this is also be equal to 1. So we know that a times a inverse is equal to 1. So we're going to be talking about this, but in context of matrices. So if you remember here, the whole point of using matrices for linear systems is we want to solve this equation. So similarly, we're just going to be trying to find what we can get. So we'll have and solve for our variables and solve the mystery. So now let's see how we can find inverses of matrices. So the only matrices that we are going to be concerned with are square matrices for matrix inverses. So that means that we're dealing with linear systems that have the same number of equations as the same number of variables. So let's think our basic example. If we have a linear system with 2 equations and 2 variables, we'll have a 2 by 2 matrix, right? So let's try and see if we can find a 2 by 2 inverse. So if we have a 2 by 2 matrix, let's just define a generic 2 by 2 matrix as A, and we want to try and find A inverse. So the notation always is whatever our element is raised to the negative 1 power, and this is going to denote inverse. So now we're going to take our formula. Formulas for 2 by 2 inverses are going to help us. Unfortunately, once you get up a little bit higher, we're not going to have this kind of formulas, so let's just bask in the moment right now. Okay, so here's our formula. So we're going to take the product of the diagonal going down, which is AD, and we're going to subtract the product of the diagonal going up, BC. Okay, so this scalar is actually just going to be multiplying by our matrix. But I have a little secret to tell you. This denominator here, that's called the determinant. We're going to get there soon, so get excited for more exciting things to come in linear algebra. But for right now, don't worry about it. Just think of this as a scalar that we're multiplying our matrix by. So now, we can't just keep the same matrix. So what we're going to do is we're going to do a swap right here. We're going to swap these two. So we're going to have a D, A, and then we're just going to swap the signs on B and C. So we're going to have a negative C here and a negative B up there. And then this is our formula for A inverse, or the inverse of any 2 by 2 matrix. So let's try out an example. So if we have B, which is a matrix, negative 2, 4, 1, 1, and then let's see if we can find the inverse of this. Let's make that a negative, just for fun. So, to take B inverse, we are going to take the product 1 over the product of this, so negative 2 times 1 minus this product, which is 4 times negative 1. And we're going to multiply that by this matrix where we switch these two terms. So then we have a 1, negative 2. And then we're going to just swap the signs here. So then we'll have a 1 here and a negative 4 up there. Okay, but we're not done quite yet. Now we have to simplify this down. So we see B inverse is equal to 1 over, so we have negative 2 minus 4 times negative 1. So we're going to have negative 2 plus 4, which is going to be equal to 2. So we just have 1/2. Oh, nice easy scalar. And then we're just not going to do anything in here this time. So this is our inverse. We can simplify it one step further to get this matrix. We'll have 1/2, negative 2, 1/2, and negative 1. So now let's try this out. Let's see if this truly really is our inverse. So we know that if it is our inverse, we should be able to take B times B inverse and get out our identity. So let's try that. So we'll take B and we want to multiply it by our inverse here, which is 1/2, negative 2, 1/2, and negative 1. We're going to see if we can get 1, 0, 0, 1. Because remember our identity, since this is a 2 by 2 matrix, we are going to be dealing with I sub 2, or the 2 by 2 identity matrix with 1s down the diagonal and 0s everywhere else, right there. Okay, so now let's take our multiplication here. So negative 2 times 1/2 is going to be negative 1. So we're going to have here negative 1 plus 4 times 1/2 is 2. And then we're going to have up here negative 2 times negative 2 is 4 plus 4 times negative 1, which is negative 4. And then we have our second row times our first column, negative 1/2. Negative 1 times 1/2 is negative 1/2 plus 1 times 1/2, which is 1/2. And then we have finally negative 1 times negative 2, which is 2, plus 1 times negative 1, which is negative 1. Okay? And now when we simplify this, we'll just bring it on down here. We're going to have negative 1 plus 2 is 1, 4 minus 4 is 0, negative 1/2 plus 1/2 is 0, and then 2 plus negative 1 is 1. Yay, okay, whew, we found I2, which means that B inverse is correct. So we have not made any weird mistakes with our formula or with our algebra over here. So we successfully found the inverse of a 2 by 2 matrix. So now what about a 3 by 3 matrix? 1 second, we'll find out.